Alright, ladies and gentlemen, literal equations basically are equations that have more than one variable.
What was this?
Equations with more than one variable. For example, here's what they're going to ask you to do. You've got this equation, 2x plus 3y equals 10. You are going to be asked to solve this. We'll do some a little bit more complicated. Solve for y. Okay. And it's a pretty simple little thing. And as a matter of fact, it almost seems to me like we have done this before. Okay, but remember, it's the same as solving any other equation we've ever done. Your goal, in this case, you want to get the y by itself. Okay, you want to just you want this to say y equals something. Okay, and remember when we did other equations, when we were solving for x or whatever it is, you always get rid of the addition and subtraction stuff that's with it. As it is right now, you need to get rid of this 2x and you need to get rid of this 3 in front of the y in order to get the letter y to be by itself. You always, the last thing you do is you always divide by what's in front of the letter, that numerical coefficient as it would be. Okay? So the first step is always to move the addition and subtraction stuff over. Move the addition and subtraction stuff. So this is going to, I already mentioned that, I'm not using the brush here. Okay, so the first step is going to be I'm going to subtract 2x. Okay, now you'll notice, children, in our rules of combining or combining like terms, the only way you can put a 2x with any other term would be if it's an x term, and this other side doesn't have an x. So the only thing you can do is this. I'm going to rewrite the 3y. The only thing you can do is move this 2x over and write it like this, because it doesn't go with the 10. They're not like terms. You can't put 2x with the 10. Now, why didn't I write it as 10 minus 2x? Because in math, we always put the things with the variables first. Is it wrong to write it the other way? No. But when I read the answer, I'm going to say the x term first, just the way they do it. It's just a matter of consistency.
Isn't 2x minus 2x 0?
Sure. That helps you. But it went away. It's gone. There's nothing there.
Then how does the negative 2x appear?
Because what you do to one side, you have to do to the other side. You can't just subtract something from one side and keep it balanced out. That's the rule of the equation. Now, just like before, how do I get rid of the 3 in front of the y? It's division. But what I do to one side, I have to do to the other side. And there's two different ways that this can look. You can either put a line all the way over this, but generally speaking, we don't like it that way. Or you do each one individually. In other words, you get negative 2x divided by 3 plus 10 divided by 3. It's the same thing, but we usually go this way because if you can simplify the numbers, this makes it a lot easier. And this, ladies and gentlemen, is a literal equation solved for the letter y. And I could do the same thing for x if I wanted to. I always look to see if I did something wrong. Okay, I don't see anything yet. John?
So you can just take it like that, you don't have to stay on that. You don't actually have to divide it out.
Well, you can't really divide it out. There's nothing you could do. You could get a decimal, but we'll just leave it as fractions. I mean, you get a 0.6x and 3.3 repeat or whatever it is, but no, this would really be as simplified as you can. And the reason they have you do stuff like this is because this is a linear equation with slope and intercept. That's the reason why they do this one. But that's not, we are not limited to those type of equations because here's problem number 2. Ooh, Nick?
Wait,
Two
if it
Nick.
was like
2 Nick.
9 over 3, could you like?
Yes, this reduced down to 3. And that's why you kind of do it separately. Check this one out. This one gets a little more complicated. 4p plus 2a minus 5. 4a plus 2p plus 2a minus 5 equals 6a plus p. And we are going to actually solve this for both a and for p. First time we'll solve it for a. and then the second time we'll solve for P. Okay? But this one here, before we do any of that stuff we did in the last one, you need to simplify the whole thing. Because you've got A's over here, A's over there, B's over here, B's over there. You need to put those together before you really think about getting anything down to whatever. So, it doesn't really matter which way you go about doing this. Any suggestions? Again, my goal is to get all the A's on one side and everything else on the other, so you can do yourself some favors. And what Christ says to,
Subtract the 1p.
alright, subtract this P?
Yeah.
I'll go for that. I'll subtract this P, subtract it. These are the like terms, so I can take it away from that. Now I'm left with positive 3P plus 2A minus 5 equals 6A. Suggestions on the second step, Jackson?
Subtract the 2A.
Well done, because I want all my A's on one side, so I subtract my 2A, subtract my 2A, they are like terms, so you can do that. And now I just got one thing left to get the letter A by itself, Nikki Kala, and that is,
-3. Wait, no.
see, these two have to go through some sort of warped, twisted divorce here, because they're together. You need to separate them. So how am I going to do that? Just like I did in the last one, you have to.
Divide by.
This is multiplication, 4 times A, so you're going to divide by 4, but you have to divide everything by 4 then. There you have the letter A all by his lonesome, and you can flip it over and put it on this side, it doesn't matter. For A equals 3P over 4 minus 5/4. Again, you can't really do anything else to that. And remember that 3P over 4 is the same thing as 3/4 P. That is the same thing. You can move it from the top to the outside, but you can't, it's not the same thing as 3 over 4P. That is different. Okay, 3P over 4 is the same as 3/4 P, but you couldn't make it 3 over 4P. That is not right. Simply because if you were to multiply it together, P goes over 1, and that's what it ends up being over there. Nick Shanks?
Should we make 5/4 and next
Nope.
word?
Nope. In upper level math, as long as it's reduced, you can keep in proper fractions all you want. Now, let's say I'm solving it for P. How would that look differently? Let's go all the way back to the beginning. Let's do the magic of the board. How long will it take me? How long? This looks fun on the film. So if I'm solving for P, what's going to be different? Say Ty, first thing you'd probably do is?
Subtract something.
Sure. Remember, I want all the P's on one side, everything else on the other. So you have a couple choices, actually. Which one would you prefer me to subtract?
That's 2A.
Subtract 2A, that's what I probably would have done, actually. Subtract 2A, so I end up with 4A over here. Lucas Espanol?
Subtract P.
Okay, kids are way too smart. Subtract P, now I get 3P minus 5 equals 4A. Yeah, now, John Nyer, add 5. It doesn't go with the 4A because it's not like term, so I end up with this. And then always you'll find your last step is to do this. Always the last step in solving these, Jack, is to
Divide the 4A. Separate the 3P.
Yeah, we'll go through a nasty divorce here. And that is, ladies and gentlemen, your answer. Solve for P. The other time you solve for A, this one is solve for P. Now, practical applications. I love this one. What?
So for that one, would it be 4A divided by 3, or would it just be 4 divided by 3A?
Now, the A number goes with the 3. You can either write it as 4/3 A or 4A divided by 3. That's the same thing. But you can't put the A at the bottom.
Yeah.
Perfect. Practical applications. Let's go to weather with the incredible amount of snow we're supposed to get here. Celsius equals 5/9 Fahrenheit
Different page.
No, you can do this on the same one. That is the formula to find Celsius if you know what the Fahrenheit temperature is. For example, let's just for fun plug this in here. If I know that it's 32 degrees out Fahrenheit, 32 minus 32 is, times 5/9 is, so Celsius is 0 degrees when Fahrenheit is 32 degrees. The other one we know for sure is 212. If I put 212 degrees Fahrenheit in here, subtract 32 from it, I get 180. Guess what 180 times 5/9 is? Take 180, divide by, just cross it off to give you 2. 5 times 20 is 100. So when Fahrenheit is 212 degrees, then Celsius is 100. But what if I knew the Celsius degree and I wanted to find the Fahrenheit temperature? Well, that means we need to change our formula. I want to change this. I want to change this and see what my formula would be if it was the other way around. In other words, I want to solve this. I want to solve this for the letter F. Anybody thoughts? The first thing you need to do is, believe it or not, Jeremy? Sure, fire me the formula. We'll see if you're right.
1.8. No.
1.8, so that would be 9/5.
Really?
Yeah.
And
Might be
there's
right.
C plus 32.
That might be right. I don't know.
It's in our assignment book somewhere.
What?
It's in our assignment book somewhere.
What's?
Well,
Well, I don't know. It could be right, but let's look and see. Here's what you would do. First things, you got to get rid of this parenthesis. So you have to do the distributive property. You're going to have to multiply this times this and that times that. So you end up with this. Take my word for it. 5/9 F minus 32 times that is 160 over 9, correct? Is that right? Because 32 times 5 is 160 over 9. Alright, now following the same rules, if I want to solve this for the letter F, I've got to get the letter F by itself, so I need to, I want to get the letter F by itself, same rules we just did. First thing to do, get rid of the addition subtraction stuff, Corinne. Huh? Addition subtraction stuff first, so I would, you're going to add 160 over 9 to both sides. So this side over here equals C plus 160 over 9, and that equals 5/9 Fahrenheit. Now, how do I get rid of the 5/9 in front of the letter C? Nick Shanks?
You multiply it by 2.
Which is
9/5.
9/5. Okay? So now I got to multiply both of these by 9/5. So 9/5 times C plus 9/5 times 160 over 9. And like Jeremy said, I believe, well, this will cross off. 5 goes into 160, how many times we did that? That's 32. But did you say parentheses, Jeremy, or did I put the parentheses in there? No, well, that wasn't in my. So Jeremy was correct because you end up with the letter F equaling 9/5 C plus whatever this is, which is 32. 9/5 C plus 32. Which, if your Fahrenheit temperature is a multiple of 5, makes it really easy. For example, if it's 20 degrees out, 20 degrees Celsius, 5 goes into 24 times. 4 times 9 is 36. 36 plus 32 is 68. Is 20 degrees Celsius equal to 68 degrees Fahrenheit? Probably. If it was, I don't know, something else, it would be something else. Oh, here's a couple more. Under the same piece of note, people. Everybody knows the formula that distance equals rate times time? distance equals rate times time. With 3 of these different variables, you can solve this 3 different ways. We solved it for D. What if I wanted to solve it for R, Nick? What would I have to do? By what? No. Why
By T.
Why would I divide by? No, I don't want.
Divide by T.
I want to get the T away from it. So I divide by T. So R equals T. R equals D divided by T.
That's actually, I would divide R.
Rate equals the distance divided by time. That's not right, Nick?
Actually, that is very much correct. That is, it's just I was about to point out, that is just another way to put down the formula for other, it's like another way of putting down a formula for rate. It's just another way of putting that formula, but in entirely different ways.
I want to say yes, even though I don't. What if I wanted to solve this thing? If I had D equals R times T and I wanted to solve for time, you divide by the R. So time equals distance divided by rate. How long does it take you if you're going 200 miles at 50 miles an hour? You get that. So you get this equation, you got this equation, and you have the first one that we started off with. You could change all of those with this little helpful thing. Ooh, that was exciting, wasn't it?
Yes,
I thought you probably would enjoy that.